Another kind of function you can have is a function defined by two or more equations over different domains, so different x values. So it's when you have different pieces of a function, so they're called piecewise. You've seen these before. So what's important is to look at what's the function and what's the domain. So the function I'm going to use of x squared plus 1, I'll use that if x is less than 0. So any number where x is less than 0, I would use x squared plus 2. And then anything where x is greater than or equal to 0, so 0 is included in this one, equal to, and then I would just use x minus 1. So for these, you just need to decide which function, which equation do you use. So if I have f of 0, well, which one includes the 0? And remember, we said the equal to includes the 0. So we're going to use x minus 1 for this one. So we're going to use x minus 1, and we know that then that f of 0 would be 0 minus 1. So f of 0 is negative 1. Pretty simple. Just decide which one to use. And then the next one here, we have f of negative 2. So negative 2 would be less than 0. So we're going to use x squared plus 1. So we would use x squared plus 1, and we would say f of negative 2 is parentheses, very important, especially when you have that negative squared. So negative 2 squared, anything negative squared is always positive. Negative 2 times negative 2 is positive 4, plus 1 means that f of negative 2 is positive 5. And letter C, f of 1, that is a positive 1. So positive 1 would be greater than or equal to 0, so I'm going to use the x minus 1 again. So f of 1 would be 1 minus 1, so f of 1 would be 0. So for piecewise functions, just decide which function does your x value fall under. And then finding domain. Domain are your x values. Okay. And when you're given something like letter A, your domain is listed out for you. Right? When you look at letter A here, your domain are all of the x values. Okay, that's it. This is called an explicit domain, where they explicitly tell you these are the x values. So for this one, we would say our domain is the set of numbers, and then we would just list our numbers, normally in numerical order, and they are set up in numerical order for us. So negative 3, negative 1, 0, 2, and 4 is my domain on this one. Now the other three are what we called implied domains. And what that means is it's all real numbers. It's any x value unless there is a denominator, the division by 0. Okay. So for the example that they give us, right, here, our denominator, what's important when you're looking at the domain here is your denominator. Okay. This cannot be 0. So what I would do is I would say, well, x squared minus 4 cannot equal 0. And then I would solve. So I would add 4. Go over here, x squared cannot equal 4, square root, x cannot equal plus or minus 2. So notice how they say the domain is all real numbers, all real x, other than x equals plus or minus 2. So that's what we'll do for everything here. So for letter B, this cannot be 0. X plus 5 cannot be 0. Otherwise, I can put any x value in there that I want to. So if we solve here, we see that x cannot be negative 5. So your domain is all real x, except x being negative 5. So denominator can't be 0. Letter F doesn't have a denominator, so there's nothing to worry about there. There's no square roots. There's no absolute values. So here there's no denominator, there's no square root, there's no absolute value. So in this case, this domain is just all real x, all real numbers. There's nothing that it cannot be. There's not an x value that I cannot substitute in here. And letter D, we have a square root, okay? Now, we talked about earlier a little bit that we can't take the square root of a negative number and get a real number. And we're focused in on real numbers here, not imaginary. So whatever's under the square root cannot be less than 0. So what we would say then, how we would set this up, is we would want to say that whatever's underneath the 4 minus 3x, it has to be greater than or equal to 0. We do not want it to be negative. So we're going to set it up where these are all the numbers that can be included. It can be greater than or equal to 0. So then if we solve, and then here we have to divide by -3. Remember, when we divide by a negative and we're solving, we need to flip that sign around. And then we have two negatives which divide to positive, so 4/3. So x has to be less than or equal to 4/3. It cannot be anything else. So this is our domain. X is less than or equal to 4/3. It could also be written as that interval that we've talked about, where 4/3 is the largest it can be, but then it can go to negative infinity for everything less than that.